Let's talk about what science is, or better yet, how science is established. What I think of when I hear the word science in general. You see, science to me is not just a book of information. It's not just a bunch of data that's collected, a bunch of arguments that are being made that are all printed out and put neatly into a book. In this book, it says science is a key to the future. And to me, that is the real power of science. You see, science as a key to the future is what allows you to be able to make predictions about the future. In this respect, this key, the answers, if you will, the answer key to the future is the predictions that we can make. But these are generalizations. There may be explanations about how things work. But the question is, where did this book come from? How do we establish that this is what science says? You see, science has an interesting relationship with time. Science has this thing called the problem of induction. The problem of induction speaks like this. As future, we look ahead. We predict what's going to happen. And as we talked about as far as inductive reasoning, it goes that we make specific instances and we make generalizations. If you remember the Yoshi, specifically, this Yoshi is green. I collect enough Yoshis, I eventually join the generalization that all Yoshis are green. We know that some Yoshis are blue, yellow, pink, so on and so forth. But that's not all of it. It's not just outliers. You see, science, as the key to the future, communicates something very interesting. We can't sample the future, no matter how much we try. It's not just that there might eventually be a Yoshi that's green. It's that whenever we sample the future, it flows through time and eventually becomes the past. See, the hourglass is running. As it collects the data, it's now in the past. And I'm making predictions about now the empty top, which, honestly, I've never sampled.